Good morning. Today we're going to learn about Newton's third law of motion.
Hey guys.
Hey Bo.
Hi Bo.
Flippin' physics. Newton's third law is an equation. For every force 1, 2, there exists an equal but opposite force 2, 1, where both forces are vectors. Newton's third law. For every force 1, 2, there exists an equal but opposite force 2, 1, where both forces are vectors. Every force is the result of an interaction between two objects. In this equation, the objects are object 1 and object 2. So F sub 1, 2 is the force from object 1 on object 2, and F sub 2, 1 is the force from object 2 on object 1. Let's take a look at our first example. As the ball collides with my head, there are two equal and opposite forces. The force the ball applies on my head, or force 1, 2, and the force my head applies on the ball, or force 2, 1. Those two forces are equal in magnitude and opposite in direction. These two forces are called a Newton's third law force pair, and it is important to realize the two forces act on two different objects, the ball and my head. That was good. I like that one. The force the ball applies on my head is equal and opposite to the force my head applies on the ball, a Newton's third law force pair. Now, you may have heard for every action there is an equal and opposite reaction. However, I'm not really a fan of this version of Newton's third law for two reasons, both of which are illustrated well in this home video of ours from 2007 when Genevieve was 4 and Ryan was 2.
Why don't you guys do it together? You know, you want to take a turn?
Oh, I want to take a turn by myself.
Okay.
Ron, I want to turn with myself. Help!
Genevieve, calm down. Genevieve, calm down.
Ryan is wrecking my turn! Ryan, you're wrecking my turn!
Genevieve, you can have a turn next, honey. Yes, you can, honey.
But I was waiting in line.
You know what? You were waiting in line. And you know what? I'm sorry, Ryan probably shouldn't have gone.
The action here is Ryan taking Genevive's turn, and the reaction is Genevieve getting upset. For every action, there is an equal and opposite reaction, right?
But that has nothing to do with physics.
Exactly. The terms action and reaction here are unclear. Newton's third law has to do with forces, not actions. In addition to that, the two forces act simultaneously, and the terms action and then reaction imply that the two forces are not simultaneous. Also, Newton's third law force pairs are sometimes referred to as action-reaction pairs. Bobby, remind me, what is a force?
A force is the ability to cause a change in state of motion of an object.
Or you could just say the ability to accelerate an object.
Let's do another example. A hammer striking a nail. Billy, what is the Newton's third law force pair in this example?
That would be the force the hammer applies to the nail is equal and opposite to the force the nail applies to the hammer.
Bo, what evidence do we have that the hammer applies a force to the nail?
The nail starts out at rest, and when the hammer strikes the nail accelerates, so the hammer applied a force to the nail.
Correct. And Bobby, what evidence do we have that the nail applies a force on the hammer?
The hammer is moving at the beginning, and when it strikes the nail, the hammer stops, so the hammer accelerates because the nail applies an equal but opposite force on the hammer.
Let's do another example. Let's go to Kevin Zhang, our flipping physics correspondent in China, to discuss this example.
I'm here on the Great Wall of China to prove that Newton's third law still applies, even with something as vast as the Great Wall. Note that we know the wall applied a force on me because I experienced an acceleration to slow me down. I also applied an equal but opposite force on the wall. However, its mass is too large for me to change its state of motion. This is exactly what happened with your wall back at home, Mr. P. So there you have it, Newton's third law on the Great Wall. This is Kevin Zhang from Dandong, China. Back to you, Mr. P.
Thanks, Kevin. It looks like Newton's third law works on the other side of the planet, which is good. Thank you very much for learning with me today. I enjoyed learning with you. Good morning. Today we're going to learn about Newton's third law of motion.
Sorry, I keep saying silly.
Good morning. Today we're going to learn about Newton's third law of motion. That was perfect. We're going to do it several times.